It says you're offline, or MIT Battlecode is offline. Oh. It is no longer offline.
Cool.
Alright.
Let's bring up our videos.
Hope your computer doesn't die.
Yeah, wait, so like, I think if my computer dies, if chat complains, I will like close our videos, right?
Why am I bigger than you?
Because this is the default messenger setup.
Oh, I see.
I don't
think we need to be that big. You can make us a little bit smaller. Oh, I guess I can't see you.
This is also as small
Wait,
as
you can't, just don't use the default one.
Wait, this is also as small as it gets. It won't let me
No, don't use the default. Can't you just like, I'm pretty sure we can be next to each other. Maybe I'm not. Wait, maybe we cannot. Alright, perhaps
I think
we cannot be the same size.
Yeah,
this is fine.
This is jank, but I think you will be big and I will be small.
This is like, alright, good morning, afternoon, wherever your time zone is. We are back, and today we will be giving you like a how to Java crash course. This is kind of assuming that you have had some form of programming experience before, because I guess it's hard to teach you how to code from scratch in 2 hours. But yeah, so let's just jump straight in. And if you were here yesterday, you would remember that my stream was lagging a lot, which is why today Nathan is streaming, and I'm just on a video call with him because, yeah, can we get a setup tutorial? Should that be tomorrow maybe? Because we did not prepare that right now. But
yeah.
Okay. How long is the stream? It could go up to 2 hours. I don't think we will actually take up 2 hours. Basically, we're going to go over like some basic Java stuff and then give sort of like an overview of the robot player.java. If you have other things to do, you can just come watch this recorded stuff later and skip around if you want. I would not be offended if you want to leave right now. Alright. But yeah. We'll try to go pretty fast, I guess, but if you have questions, just ask in the Twitch chat. We are watching a Twitch chat. We are currently on an online sort of IDE. It's called REPL.it. Basically it's like Google Docs for code, kind of, so we can both be coding, which is why we're using it. But I do not recommend coding online for the if you're actually programming your bot. I personally use VS Code when I did Battlecode stuff. I used to use Eclipse for things. IntelliJ is really cool too. Whatever you want, basically. I don't think the editor matters that much.
Don't use Google
Sublime.
Docs.
Okay, don't use Google Docs. Don't use Google Colab. Terrible idea. Okay, Nathan, can you scroll to the top of the file?
Oh, yes.
So now let's get started. So I'm gonna go over some. That's not the top. That's the top of the file. Okay. All right, we'll go over some basics. So in Java, just like in every other programming language, you can have conditions and if-else loops. The specific syntax is like let's assume I have a variable x. We'll go over the stuff later and how that works. So let's say we have a variable x. It has value 0. I can do if x equals 0. So this is like checking if x is equal to 0. Do something. Print line. I can't spell. X is 0. Whatever. And then you can do else. System.out.println. So this is how you would print things to the console when you're running a program in Java. Then you're like x is not 0. So if you run this, this first line will be printed. The syntax for if-else's is the condition needs to be in the parentheses, which might be different from some other programming languages. And all your blocks have to be wrapped in curly braces. So, well, if the block is only one line, you don't actually need these curly braces, but it's better programming practice, and now you can have like multiple lines of things. Another thing you can do is, you can do else if, all right, x equals 1. There, all right, and then kind of system.out.println, x is 1. All right, so then this condition only evaluates if the first condition is not true. So if I have like x equals 0 and this is like x less than 1, this will never be printed, whilst this will get printed because it is like intuitive. All right, and then yeah, while loops. So then you can also do, so while loops is like similar to other programming languages. The loop will execute while the condition is true. So you can do like while x is less than 10, x plus plus, and then this will keep executing until x is no longer less than 10. So if I print out x at the end, it should give me something that is not less than 10. So hopefully I don't have any random errors here. if I run this code as expected, it prints x is 0 with a typoed parentheses because x is 0. And then it comes to the while loop. It keeps incrementing until this condition is no longer true, and it prints out x. For loops. All right. For loops are convenient because you can use like arbitrary conditions to get the loop keep running. It's a specific Java syntax is for, and within this parentheses, you can have an initialization. So I can go like I equals 0, and then this is like a very common loop. I less than 20 or something, I plus plus, and then in here system.out.println I. All right. So what this does is this is initialization. This is the condition that must be true. So actually, this like I don't want to call this initialization. This is something that executes before the loop runs. This is something that must be true for the loop to keep running. And then this last thing is something that will happen at the end of every loop. There are lots of things in the Twitch chat. Nathan, you can look at it now. I'll finish this chunk.
No, I've been looking.
So any of these three things can be empty. Like I can totally do this, and I'll do like I++ in here, and that's like totally valid, and the loop is like fine. I can also do like this, and that's also okay. But yeah, if we run this, it should like as expected, it will print like I is 0 up to I equals 20, and that is the basic loops and if-elses that you will use a lot when you're programming basically anything. All right, let's take a break and take a look at Twitch chat. Place where you put your code. I don't remember what the distribution is like. We can go, yeah, I will ask the lecturer tomorrow to do like a setup tutorial since we didn't prepare this, unfortunately, and I don't have the stuff open. But deepest apologies. But yeah, you already have lots of Java, so you can, the way we did it is you like define your Java home variable to point to the one that's Java 8. But if someone else has other solutions, feel free to use that as well. If I were you, a lot of people are having these problems. Yeah, there's a lot of setup like help in the Discord. That would be very helpful, probably. Yeah. How long would today's stream be? Honestly, probably like an hour or so. I think we can be done. All right. How fast do I type? Type rate sometime. Okay. Okay, Nathan. Why are you streaming and on a different account at the same time? All right, Nathan. Go over the next part.
Yes. This is also me. I haven't signed out on the thing on the browser I'm watching from.
Right.
Yeah. So most of your line syntax actually matters a lot. I also realized that if I click, the video call goes away. So bye for now. Sorry. Yeah. A better setup would come if I had some more time to figure out XSplit. Like I know what to do, but I didn't get to. Semicolons, you want semicolons at the end of most lines. Basically, every line that you're telling your code to do something, you want semicolons. So not the best definition, but you'll definitely get a hang of it. Basically, semicolons after every line, other than a few cases such as if, else, while, and for.
I think just like things that come before the curly braces don't need semicolons.
Yeah,
because it's not the end of a command, basically.
Basically, the semicolons are for lines after commands. Everything else is you use for like the if statement, for example. You have your conditional x == 0. You wrap that in parentheses, and then immediately after you signify what commands are in this by wrapping your commands around curly braces. Yeah. So curly braces around these code blocks like this, parentheses around conditions, and semicolons after practically everything else. Another thing that's especially different from Python is that like white space indentation doesn't matter. We wrote in our notes, but like really white space doesn't matter for the most part. I think. Yeah. White space doesn't matter. Your code will compile fine. You could write this all in one line. But yeah, please don't. Make your code format at least nicely, because it's going to be, a lot easier to read, a lot easier to work with. A lot of IDEs have like automatic formatters for you that'll take care of this and format your code to some nice looking thing.
All right, types, Java types. So as
Hello again.
okay, yeah, that's actually in static typing. But so the types in Java, we have like normal things like integers, which are up to 32-bit numbers, longs that are like 64-bit numbers. So you can like give like a huge number. When you do longs, you want to actually have like an L at the end to specify that it is type long. If this number is less than like the integer cap, you don't actually need the L, but it is general like decent practice to actually like have this L at the end. Doubles are your standard floating point number. I cannot use X anymore, so you can like some floating point number, anything. It's some bit precision, but you will never like need to worry about that, at least for Battlecode. Floats are like smaller doubles. We do use these somewhere like through the code base, which is why I'm like bringing it up. And floats are basically like lower precision than doubles, save more space. Yay. So for these, you do want like an F at the end to signify that it is float. There are other data types for integers like short, byte that are like basically smaller than ints, but you basically won't use these. Boolean is your standard Boolean. True or false. Okay. And these, unlike other languages, sometimes it is all lowercase. You also have chars, which are basically characters. So how you do this is you use like single quotes, and you have like, yeah, some char. So this can also be like the new line character, a tab, return, any of those things. But most standardly, they will be like some digit or some alphabetical character. And then, all right, so now some things you might want to know in Java that is like weird. Primitives are not actually true numbers. So they are theoretically numbers and they work for most numbers, but there are some special cases. So most importantly that you might need to use or will encounter is integer division in Java. So if I have int b equals like 5 and I have int c equals 2, I do int d equals b divided by c. All right, so this works, and this is what we call integer division. If you're dividing an integer by another integer, this will actually give you 2 instead of 2.5. It's not 2.5, it will give you 2. So it basically floors the number. You can think of integer division as like math.floor b divided by c, like assuming that this is like true division. So if you want the remainder, you do like b mod c, which will give you, this will give you 1.
Wait, Elizabeth, are you typing? Have I disconnected?
Oh.
If you're typing, I can't do it here.
I am typing.
Oh, oof. Thanks for that.
Shoot.
Let's try refreshing. Have you disconnected or have I?
Good question.
I'm just going to try to refresh the page.
Maybe I will refresh as well.
So the REPL like has been updating until now really fast. So both in testing and at the beginning of this lecture too. I think at least one of us is frozen.
Can you scroll down?
Okay, now I see things.
Oh yeah, so integer division. It's annoying if you don't like it. It's cool if you want to use it. It's like similar to Python's like double divide. Well, I forgot what it is. There's a thing in Python 3 that like does the same thing. But yeah, so if instead I have double c equals 2, even though this is like an integer, so first of all, this is like illegal, I believe. This is going to give you a compiler error because you cannot do like int equals like an int divided by a double. If we actually try to run this code, it should catch it as a compiler error. But if I do this, d will actually be equal to like 2.5 because one of these things is a double. So if either b or c is a floating point, then the result will be a floating point. All right. However, something that I can do, so because like running on repo.is is like pretty slow, so I'm kind of just like walking through what would happen without actually running it. I can do this.
Typing is broken again.
I'm
not getting updates from your end.
Is this like my internet or your internet?
I don't know. Maybe I'll try typing. Do you see things on your screen?
Well,
not that it matters. Okay.
I do not see things on my screen.
Yes, I continue. I don't know. This is...
Sorry
for technical difficulties. I could try refreshing again. Yeah. Want to take a Twitch chat break?
Alright, let me see.
Have you been? So I reloaded. Have you been typing anything? I can't tell. There's nothing.
I have not typed things. Maybe I need to reload.
So Steph has suggested suggested that you dictate again. We thought about this, and this is why we tried REPL, but now that REPL is broken, maybe this is something we have to do. Do you want to try dictation?
All right. Okay. All right. So that is integer division in a nutshell. It's like basically math.flow. There's also integer overflow. Can you just like write like some integer equals integer on max value?
Yeah.
So you can use these like predefined. I'll talk a little bit about what integer is, like this typed out integer is. So that's basically like the maximum value of integers. So because integers are 32-bit numbers and it's like signed, it's basically like 2 to the 31 minus 1 or something like that. So if you do like huge integer max value plus 100, huge will actually be a negative number. Can you try running that?
Well, yeah. Wait. So I put in some syntax errors. I stopped it and let us rerun. Stopping takes a while for some reason. I think because it's all running remotely.
Yeah. So basically, what this does is like just think of all the numbers as like on like some line. I don't know. This is a terrible analogy, but basically, it will like wrap around the largest value and go to like the smallest value. This is called overflowing, and we do have an overflow bug in the engine right now because of terribly designed slander influence no cap. That will be fixed soon. But yeah, so this will happen. So you definitely want to be careful when you're messing around with large numbers. If you don't want overflow, easy solution is to use longs instead of integers. And yeah, don't redeclare variables. I'll talk about declaration versus initialization. You will talk about that like right after. All right, so integer overflow. There are also special floating point values that you might want to use. Yeah, no cap. I know, terrible joke. So there's NaN, which stands for not a number. Okay, so now that thing finally ran. Basically, huge is like some large absolute value negative number because it took like a large positive number and then it wrapped around basically. So not a number is it's a floating point value, but it like basically signifies not a number. So that, and then there's also positive and negative infinity, and how you can like run into these when you don't expect to. If you have like division by 0, instead of like throwing an arrow, sometimes it will like just give you positive infinity, and so that might be confusing. And it's good to know that these things exist.
How do you make new floats again? Well, I was gonna do 100 divided by 0, which gives you like.
Oh, you can just try 100.0. 100.0 point. Yeah, that would. Yeah.
0.0.
Yeah, I don't know if this works. This should work. Run it. Okay. Let's see. But yeah, this is basically things that happen.
Jank idea says you can text me code in Messenger and I'll run it, but this is incredibly jank. Ta-da! There's infinity.
Jank. Yep. All right. So these things happen. Now there are also objects. This is actually so hard dictating. All right. So objects in Java are basically anything that's more complicated than a primitive. If you notice, all these primitives, their type is all lowercase, and objects, on the other hand, the type is always like normally written. Like the first letter is going to be an uppercase. So an example is string. Like string is basically string everywhere, I guess. It's a series. It's like text, a series of characters. So for Java strings, you need to use double quotes.
Yeah, so I've been running too much JavaScript.
The difference between strings and chars, which are like single characters, is you have to use double quotes, so that like differentiates like a character C versus a string that's just like C. So yeah, now since string is an object, you are able to actually call methods on this. We'll talk about object methods later. You can just give like a quick example: s.substring, substring like look, and then like just print out a substring. Like I should put in indexes like 0. That's not a thing. That's my dictation is terrible.
I've also forgotten.
Just put in like 2 numbers, 0, 5 or something
like that, right?
Yeah, so that works. And then if you run that, it will print. So this is like substring is just some method that gets like a substring from a string. So now there are also other. Oh yeah, so I was going to talk about the integer. So as you saw earlier on line 49, there is integer.maxValue. Basically, integer is a wrapper class for int. And the reason why this exists is so you can use integers as objects. You can use them as a generic, which is something that we won't cover today, but you can look it up if you're interested. Generics are basically, actually we will run into this a little bit. So just wait a little bit, I guess. You can also like use methods on integers, but you can't use any methods on ints because they're primitives. Yeah. Let's see, wrapper classes, custom objects. So you want something you might run into, or something you will run into in an engine is we have a lot of custom objects. Let's see, is direction and a good example?
It's like reasonable.
Direction is an enum. Body enum is an interface. We're gonna look at that. Okay. Can you like just make a random small class and be like, this is how you make a custom.
Would you like to? Can you type still, by the way?
Can I type? Let's try. Can you see me? I'm on main.
I can see you this time. Yeah, start writing.
Oh, amazing. All right, so let's say I can say public class human. This is me defining my own object. It's called human. We can give it some fields like string name, so a human has a name, int age, things like that. And then, yeah, very quickly, how to make your own custom objects. These are things that every human must have. You can make a human by defining a constructor, and you can say like name equals John, haha. Age equals 10. Okay, so this is like, if you want to make a human, you would be like human age equals human. And this will give you a human with like name John and age 10. You can also make like custom humans by defining a constructor like this. Actually, this is less confusing. All right, so then you can assign the name to be N and the age to be A. You can do a thing. I'm frozen again.
Wait.
Never mind, unfrozen. Okay, yeah. So you can name this like the same, like name age, which can be confusing if your variables that all humans must have is also name and age, and these are the parameters are also name and age. This might be a little confusing because I'm like kind of talking about how to make objects without talking about methods and method syntax, but hopefully you can infer. But the difference is basically, if you're referring to the properties of a human, you will use like this dot name, and then the parameter is just name. If you name this like N and it's like basically not the same, then you don't even need to do this because it's implied that name will be the property name. But if you have like the same thing, then this just makes it like more obvious that you're referring to the property of the human. All right, so this is like your own class. You can like make methods that we'll talk about methods in a bit. So I'll comment this out so it doesn't ruin the code's ability to compile later if I add random things. All right, so yeah, you can make custom objects, and then your custom object can do custom things. You can like add a bunch of things down here that make your custom object like super powerful. So basically, like almost every file we have in like the engine and things that do interactive are like custom objects that we made. You might want to make your own custom objects to help with your own bot, but it's not required or anything. Yep, your human's gonna solve cancer. This is void because I uncommented this part, or this doesn't work because I uncommented out this part. And yeah, all right, we'll go back into methods in a bit. Nathan, static typing.
Yes. Okay. Static typing is the concept that whenever we created any variable, object, or whatever, like when we created a, y, if we made a human, when we created this string, you specify what the type of this variable is. Like when I say s, when I wrote down s, I had to specify that s is in particular a string, b is in particular an int, things like that, which is a very different departure from, say, Python, where when you write variables, you just write like I equals 0. And I could really have been anything. We don't provide any information about that. The upshot of this is that when you say like b is an int, your compiler and also your editor get to know that like b is an int the whole time. So now that when I see b here, this is definitely an integer. Let's say it's some if-else statements that manipulated b. At the end of it all, b is still going to be an integer, and this is a good assumption. You can use this info for checking lots of things. So yeah, always provide your type. Always make sure you know what you're working with. And I lost my train of thought. I forget. Maybe it'll come back. Yeah, state your types. This helps. Another concept is, declaration versus initialization. Saying something like this. I don't know how many i's we've used. Saying something like this is fine. Int I2. So now I have an int called I2 floating in my code. And then I can do this. This is basically short. If I said I2 equals 0, int I2 equals 0, well, this will not work anymore, but I'll use another variable. All in one. So this sets up like I will have a variable called I2, and then this line actually assigns it a value. Whenever you use variables, you have to initialize them first before you do anything. As in right here, I couldn't do, doesn't work, system.out.println, like I couldn't print I2 there. Because your variable just exists but doesn't actually have a value attached.
Hold on. I'm gonna correct this real quick. I believe you can because there are default values. Java has default values.
So I don't want to say this. It does work, but don't do this. Just set to
defaults to 0. This is true.
It defaults to 0, which still isn't like predictable. Defaults get weird. I think maybe not with Java, but with at least some languages. They will just, and with C, for example, and maybe with other Java types that don't have well-defined defaults, they'll just pull in whatever happened to be there in memory. So you get really weird results. I think some compilers, or at least some code style checkers, will prevent you from doing this. Basically, don't do it. Like, even if you get away with it, it's bad practice. Don't. Instantiation. And to make new humans, I think we talked a little bit about this. To make new humans, you could do this. I think you kind of referenced this earlier, but given our human class, any methods that are called like human, open parentheses, blah, blah, just make yourself, or make a new human. I guess we can go over this here. So this, for example, this line, for example, is we go to the human class, find the relevant method, and create a new human, initialize its name to John, initialize its age to 10. You can do more complex things with these initializers, but it's pretty straightforward. Another thing you can do is that we have multiple methods. We have multiple methods called human here, and you can use either of them. I think we were talking about method overloading more later. It's a good intro. So as in, if I happen to give human with, if I happen to do this, then we will create a new human using this method. Basically, it looks at like, okay, you provide a string and an integer. Oh, this matches up with this method here. And it will, n is not John, and it'll set your human's name to not John. Age is 11, it'll set your human's ages to 11. And this is basically how you make objects based on the classes that you've defined and how you can actually use those to do things and work with things.
Yeah, okay, so classes is like kind of confusing.
That?
We were thinking about how to explain what a class is. I guess you can just think of it as like a group of code that that helps the same thing. So like here, when I gave my like human example, I said public class human. It means like all of human is a class. If anyone here knows what classes are and has like a better analogy, would greatly appreciate. But classes just like, if you put everything in the class, it means all that code like sort of goes together in like a bundle, which like obviously for all your human related code, they will be in like a class together. So there's some better explanation on Geeks for Geeks or something probably. I don't know. Stop interrupting. Operations. Let's go. Class of students. Yeah, class is like a structure. Yeah.
Yeah.
So it's the equivalent of like a Python. Is it called class in Python?
I think it's abstractly called class. I don't know if it has a name exactly.
Struct in Golang and C, I believe. But this is when you know I'm like terrible at other languages.
Class is like a structure but fancier. Yeah, I think that's more or less it. Like classes are just like an abstract definition of what an object is, and then you actually make things. Like, I don't know, we call like playing card is a class. And then actual cards that have actual values and suits, like, I don't know, the 3 of spades, you could write as an object pretty easily. This is like not the best explanation. Just use classes and objects enough, and it becomes clear enough with like a little bit of experience.
So Nathan, I just realized you didn't give me mod permission.
Oh yeah, I forgot to add you.
Okay,
WFLMS 2011-0333 is Elizabeth.
Yes, the class is a blueprint for making an object. Yes, but not all classes are objects, which is most of the time if you make a class, it will be for an object. Can you scroll to the top? Like main is right now it's a class. It's not really an object, and we don't really make I guess it is an object. We just don't use it as an object. But yeah, it's a class as well.
We have some non.
People have some good analogies in chat.
Yeah.
I love you guys. Okay.
Oh, we talk about interfaces later. Okay, cool.
Yes.
Let's move on. Operations. Okay, so we've seen. Oh yeah. Here I did a math. Here I did an add sign. I did divide. Most of the basic things that you'd expect from like other programming languages are also in Java. So yeah, plus, minus, times, divide. Math operations, equals, other like, I don't know, logical operators. So like for Booleans, if you've seen another programming language, you can take like ands of Booleans. These exist in Java too. Okay, so that's like all the simple ones that, you know, just kind of look like regular math notation or something. To do more complex things, do we do an object method? Yes. So recall our human class, and if we were to make a human object, these methods are callable too. Well, really just this one. Like, what's the point of making methods here if you actually can't access them? And the way you would do that is something like h dot. Is roughly this notation: object period, and then the method that the method that you actually want to use. There are also things called static methods, which I think the best way, it's a little bit hard to explain, I guess. But the best way to talk about static methods, I think, are that static methods aren't inherent to an object itself, and instead they're inherent to the class as a whole. So for example, in Java, there's a class called math, which gives you access to a lot of mathematical operations. And I don't remember if you can create an instance of this math class or not, but that doesn't make much conceptual sense either, because so math provides a sign method, which gives yourself a sign function, and the sign function is like gonna stay the same no matter what. If you were to create instances of the math class, the sign function should still probably be the same. I don't remember if it's a thing, but even if it was, it'd be a thing. So even if it was, it would be the same. And so the way you get around this, the better way to write this is that sign is a static method, which means that you call it on the class itself, and it gives you results. Do we have any other static methods like in examples of our code? I don't remember.
We do have static methods in our code base, but our code base is big. Wait, can you just go back to the human example? I'm gonna just write in the human. Yeah, so our human, these first two are known as constructors, which are used for instantiating a human object. Instantiating is kind of like initialization, but it actually like fills in your object with values. And then this solve cancer is a instance method. We're supposed to talk about this later. I think I'm just like vaguely bringing it up. These are instance variables. So when we say you have a human object, we say you have like an instance of a human. And if something is an instance variable, then every instance of the human will have their own copy. So like different humans will have different names and different ages. On the other hand, if I have something like this, like num-humans, and I start that with like 0, this is a static variable. And the difference between static and instance is a static variable belongs to the class. And so like all of human class has one num-humans. Every human does not have their own copy. So like to access like these static variables, let's say we created humans already, I cannot do, can you scroll down a little bit? Oh wow, you zoomed in quite a bit.
I didn't zoom. What?
Oh, you didn't? Your computer's just small. Alright, yeah, so no. Like I'm just gonna write a comment. Okay, yeah, down here. I cannot do h.num humans. This is not a thing. See, it gives me a compile error because a single instance of a human does not have the static variable as a property. I can, however, do human.num humans. This is a thing. This works because num humans, static things, belong to the class. As Nathan was started writing a static method. So static methods and static variables basically have like static in front of it. I can do static, I don't know. What's a good example? What do humans do? I don't know.
What does the collective set of humans do?
I don't know. Run election. Alright. So let's say we have like this random method run election. Yeah, we'll go over like how methods work later. I just keep getting sidetracked and talking about things that we already brought up. So run election, I can do human.run election, but I cannot do h.run election because this does not work. There's a green line. I don't know why it's not red.
Do you get syntax highlighting or like errors or something?
Yeah.
So I don't, and this isn't being shown on stream, but yeah, just dictate well.
Okay, yeah, so this is, static methods, non-static, static variables, instance variables. Yeah, basically everything that belongs to every instance of a human. So solve cancer is something that every human can specifically call. And then name, age, these are instance things, and then static stuff with the static label, it belongs to the class. And when you access them by doing like capital human dot num humans or capital human dot run election. All right. So yeah, it's kind of like the difference between object methods and static methods. All right.
Okay. One other thing about methods is method overloading, which we kind of saw already a little bit here. But basically, you can have two methods. Wait, is this is overloading, right?
It's overloading, yeah. It's not a method, but it's overloading.
It counts. We should
just
do
make another
here. Yeah, I'm gonna do another one. Or you can type it. So basically, you can have different methods for a class with the same name, like solve cancer, and solve cancer down here. And the difference being that they take in different arguments. As in this one takes in no arguments, which is fine. And this version of solve cancer takes in one integer argument. And yeah, so they do different things. They do the like if I were to say system print, just simply print. Oh, okay, that's also what I was gonna do. Lag is a little bit annoying. Yeah, so if I were to do this, right? If I pass in solve cancer like with an integer argument, it'll do this method. So this means you can use the same method name, but you can use the same method name to configure different behavior for you. And thanks to static typing, when your code runs, your code will be like, if I was to write, h solve cancer, oh, I see no arguments. Oh, I have a method to do this that takes in no arguments, and so I will pick this one. Whereas if I passed in an argument here, it'll be like, oh, there's this method does not apply because I'm looking for having an integer argument or having an int argument, but it matches with this one, and so I run this code. And so you can provide methods with the same name to make your life easier and still have them do different things. Like, this is better than saying, like, solve cancer integer argument version and solve cancer the regular one or something like this.
Yeah, so you can see a lot of these examples in our API. Like, for example, you have sense robots, pass in just the radius, sense robots, pass in the radius and the team and stuff like that. So all those are examples of overloaded methods. I forgot what I was going to say. Okay. All right. Anyways, moving on, question mark. Yeah, we'll go back to public, private, that stuff. I know I kind of just talked about some stuff that was going to show up later already. So, array. Oh, yeah, I remember what I was going to say. So as you vaguely saw in our solve cancer int profit example, I was printing a string plus an integer plus a string. So different from like Python, for example, you do not need to explicitly cast profit into a string. You can just add it and it will automatically take it as a string. And what's even funnier, if I do like profit plus 10 plus I make profit solving cancer, so like up there an example, Java does this thing where it will just add profit and 10 as like integers. So add them together, print that number, print I make, print the number again, and then print this. But yeah, so if this is like in the front, it still thinks we're adding integers, but if I like do it like back here, I believe it just concatenates them. Yeah. I believe. Yeah. Don't quote me. I'm pretty sure that's what happens. Okay.
Yeah, it's like, I guess this is a little high level, feel free to ignore. C number, add those, get number. Number plus string, default to concatenating them. So now you have a string. String plus number, concatenate because like addition doesn't really make sense the normal way, blah, blah. This is like a little bit of a gotcha, so just be careful with things like this. Be careful with mixing numbers and strings, that sort of thing. Okay, back to arrays.
All right, arrays.
At its finest.
Arrays, your favorite best friend in coding. So I can make an array. I say int array, like my array equals new. So this is like going back to our like previous syntax. So this is like declaring, and now I'm going to initialize it, new int array, and in here I'm going to give it a number. This number is going to be the length of the array. So yeah, they're like sort of, I believe you can also do this, but this is bad. Don't do it. Everyone should do this because it's more standard. So you can do this. You can do this with like basically any object. Some of the things we're going to talk about, like maps and stuff, things that use generics, also talking about that later. It's hard for you to do this, but it's very easy to do like a human array. So you can like make arrays of like basically anything you want, or any of your like custom objects. Everything, this all works. And then you can iterate through an array with like your simple for loop. I equals 0, I is less than my array dot length. So because my array is an int array, which is, so it has like a special property where you can do like dot length. There's not really many other special properties of arrays, but this is very useful. You can do like, this is like how you would like standardly iterate through an array. My array, and you index through it with your break brackets as usual. So like that. Oh yeah, everything's zero indexed, like most programming languages except the abomination that is MATLAB. You can also do a thing that was helpful, shortened version, enhanced for loops. So how this works is enhanced for loops can only work over like list-like structure. So most your best example is just arrays. So how the syntax for that works is you do for int x and like, I don't know, integer element, haha, in my array. So it's just like, this has to match the type of your array. So if I have like a human array instead, then I'll do like int h, my human, I don't know, like that. Yeah. So this is basically saying for like every my human, for every object in this array of type human, we can like do something with it. So this is like a shorter version of the for loop and accessing it with actual array indexing. Yeah, that's most of arrays. There's a handy dandy class in Java. That's java.util.arrays. With the S, you can import it. I guess importing is a thing, like most languages. You can import it. We can talk about this at the end. Let me add this. Importing under miscellaneous. Okay, so if you can do, there are helpful things like arrays.sort, and then you can pass in your array. And then when it's sorting things that are like, if it's sorting like an integer array, it will sort it like how you would naturally sort integers from smallest to largest. If you're sorting like custom objects, it will sort it in like some defined way based on like how objects are naturally sorted, which you will not understand. So how you want to make it sort the way you want it to is you just implement comparable on your object class, which is kind of complicated. But if you want to look into that, like have sortable objects that sort by some defined order that you can customly define, just look up Java comparable class, comparable interface, whatever it's called. Yeah. And then lists. So lists are like arrays, but they don't have any defined size. So the most famous one is Arraylist. So for Arraylist, you will need to like define what type of array list it is by having these angle braces. Can you assign by index? Yes, you can assign by index. That is how you would do things. My apologies for not going over this. Yeah. So you can do my array like 3 equals like new human Alice, who is 19 years old. Yeah, something like that. So because everything is statically type checked, you cannot do like you cannot like assign like 5. Like that does not work. It will be a compiler error. Okay. So arrays have a fixed length. You cannot change the length of the array. Array lists are like lists are basically you can like change the length of it. So this is where sort of like generics come into play, question mark. So this angle braces is where you would like give it whatever class you want it to be. So this is where you cannot do array list int. You cannot give primitives to lists, sets, maps, all the other fancier data structures. This is where like you would mostly use the wrapper class for integers, and then you can also do like human whatever. So actual use of this is you can do array list integer my list equals new array list, and then yeah. So when you're creating it, this is like creating an object because array lists are actual objects. Where when you create it, you do need the constructor here. So they have overloaded methods where you can like put stuff in here, but for the most part, you create an empty array list by just like passing no parameters. You can put integer in here as well. That's not completely necessary. So yeah, usually it just infers. Now, there are other types of lists. There are like linked lists, which are like, I don't know, and they are linked lists. If you know what that is. If you don't worry about it. You probably won't need it. Common array list methods, mylist.add 0. So this will like add 0 to the end of the list, and it will like extend the size of the list. You can do mylist.remove, where I don't know if it doesn't. Yeah, so you can remove like given an index, it will remove that index, or you can do mylist.remove and you pass in like some object, which in the case of integers, it's like kind of confusing. So it will basically always become remove index. But if I had like human objects instead, and then I like pass in some human object, then it will remove that specific human object if it exists. So that is, yeah, it works better if your human object has like properly defined like equals methods and stuff, which we will go through a little bit more. Let's see what else. Other common methods, mylist.indexOf, pass in some object, and then we'll like search for the index of that object, which can be kind of inefficient depending on what list you're. Actually, all of the lists, yeah, because it just like walks through it. You can do binary search with collections. I'll bring that up. Yeah, mylist.size gives you the length of the list. This is different from arrays where you can just do .length. Note that when I do array.length, there is no there's no parentheses afterwards. This is because length is an instance variable of the array, and it belongs to like, if you're accessing a variable, you just like give it a name. While mylist.size is a method, so if you're calling a method, it always follows with parentheses, even if there's no arguments. All right, and then sets. So sets are basically groups of objects with no defined order. Like Arraylist, the order you add them in, like that is the order they're going to show up. You can add at like a specific index, so this adds like the number 1 at index 0, I believe, not the other way around. But basically, they stay in whatever order you put them in. While on the other hand, sets is like no defined order, so you can do this by like set integer my set equals new hash set. All right, so there are two main types of sets. There are hash sets, and then there are tree sets. Hash sets are very efficient, so every operation you do, wait, actually, my terrible mistake. Sets does not mean there's no order. I'm like being stupid. Okay, set means there are no duplicate elements. Okay, big correction right here. Laura, can you assign by index if my array is an... Oh, wait, no, that was an earlier question. Yes, so sets don't have duplicate objects. So a hash set is like a set that has like no defined order. Everything's like super fast. A tree set is everything is in sorted order, but of course there is still no like duplicate elements. So how you use this is like you do my set dot add 1, my set dot add 1, and then if you print the set afterwards, it will still only have one element, which is 1. It doesn't add it multiple times. It also has like other common methods, my set dot size, stuff like that, for you to just like in size equals, so you can like get the size of the set from that. We'll talk about this a little bit more, like why this is set and this is hash set. Maps are some of the main maps that you might end up using is hash map and then also tree map. Maps basically map things to other things. So it's kind of like a dictionary if your language uses that. So an example would be like map integer to string, for example, equals new hash map. Yeah, so I could do that, and then, my map. Yep, so it's like type, variable name, initialization, instantiation. Yeah, because it's an object. All right, so this would map integers to strings, and your common method is mymap.put, and you can be output in like for some string over here, misspelled. Great, this is not actually important, but, and then meant this to be a period, and then other things, mymap.size, it's like the number of key value pairs. So this is the key, this is the value, it's like the key value pairs, number of key value pairs, mymap dot contains key 4. This will return true. Oh, geez. Okay, this will return true. Mymap dot contains value. I don't know, some other string. This will return false because this value does not exist in the map. So the important thing about maps is you cannot have duplicate keys because, yeah, you can't map a key to two different things. It won't know which one you want. Oh, yeah, most importantly, map.get for. This will return some string. Yeah, so that's the point. You can like map things and then you can get it very quickly. And then you can, however, have duplicate values. So I can do like 5 some string, and this is like fine. Both of them will, if you map.get4, map.get5 will both return some string. If you do want to overwrite, you're like 4, and then I'm like new string. It will basically delete this, and this will be the result when you're trying to get stuff from 4. And yeah, if this did not exist, then my map.contains key some string would be false. Basically overwrites entries, yada yada. Tree maps are maps, but they're sorted. So it's sorted by key, so it'll sort like 4 or 5. So if you want to like iterate over the tree map in order, you can do like you can get all the entries by doing like mymap.entrySet, and this like returns like the list of entries as like integer to string mappings. You can also do mymap.keySet. It returns like all the keys, and for the tree map, all these keys will be in order. Whilst like if for a hash map, the keys will not be in order and it will be like some arbitrary order. Yep. Enhanced for loops, we already talked about that. You can do this for maps and sets as well. So like for int set element in my set, system.out.println set element. So it will print out like all the elements inside your set in order, in the order that they're sitting, which because it's a hash set, it's like some random order. All right. That is most of it. And yeah, we'll go over like set versus hash set and then map versus hash map a bit. Object references, Nathan?
Yeah. Yeah, I was kind of lost in thought about this because I'm not sure what the best way to describe this is. So, Elizabeth, feel free to like jump in if you have thoughts. At chat, I will be looking on my other laptop too. But I think the best way to describe this is that when we've been doing all of this, let's say human h equals new human. Under the hood, Java kind of treats treats human h and the human that pops out of here as two different things. Let's say I think h2 was a human that had like a human with name like Anna, I don't know, age 37. And so the value, like h2 is a variable whose value is this. And like if I did let's say I made another human called like h3, okay, let's just use this original example. I'll call you h3. And h2 was a human with name not John, age 11 or something, doesn't matter. And so when you do, so this is how Java kind of represents its variables, keeps track of things under the hood. And this comes with some interesting consequences. As if I were to do h2 equals h3, no, h2 equals new human, if I were to do this, and then that would turn, then Java would link h2 to a new human object that I create, like a new human named James, age 12. h2 would point there, and so if I asked, say, if I asked that like system.println or system.out.println h2, it would print out the info relevant to this. And so the big gotcha here is if I were to do h2 equals h3. These two are both variables, and what this does is now it takes h2 and it has it represent the original value of what h3 has it represent whatever the original value of h3 happened to be. That is that like h2, so it sees h3 on the other end. It knows that h3 is a variable. It digs up the object that h3 variable is associated with, and it will get h2 to point to that. So h3 points to human, h2 ASCII art points to the same human as well. And now h2 and h3 are pointing to the same thing. h2 and h3 are both references to the same actual value under the hood. And that means if I say h3 equals, let's make this yet another human. And now what this will do is change h3, like go into h3, find wherever it's point. It'll create a new human called not Anna. Point h3 to this. Wait, this is wrong. Sorry. Yeah, point h3 to this, and h2 will still continue to refer to Anna. I am like mixing up languages right now. Wow.
It's okay. All right, I can jump in for a
Yeah,
little
there's
bit.
like one other gotcha here.
Alright, so like assuming this didn't happen yet. Alright, so now assume H3 is Anna, and then H2, because we just assigned it to point to the same object that H3 is pointing to, H3 is also Anna. In this case, they're pointing at the same person. So if, let's say, we somehow did this, H3.name equals Annabelle, because Anna decided to change their name. Now, if we look at what H2.name is, this is actually also going to be Annabelle, because they're pointing to the same object, and when a property of that object changes, it changes for like, it just changes. Yep. Oh, you've been saying gotcha? I always thought you were saying gotcha, like gotcha games, and I was so confused. Okay. So yeah, so up here, this is an example of reassigning variables, where like we are reassigning H2 to point to something else, but this human named James is still 12 years old. It's just H2 no longer points to this human. Okay, like nothing about James changed. H2 is just pointing to someone else. On the other hand, this is a case of mutating the value of a variable. So we're like physically changing the properties of the human named Anna, and by doing that, like everything that points to that Anna human would have like the updated values, which is her name is now Annabelle. So yeah, be careful when you are mutating values, because like everything that's pointing to your objects will have the updated values. If you reassign variables, things might get permanently lost, because yeah, like when you do H2 equals H3, then this James person is just like blown away in the wind. You will never find him again because there's nothing pointing to it. So yeah, that's basically what we wanted to go over. Something you can know is you can have unreassignable references. So I do like final int xx equals 7. Let's go back. So if I set int xx equals 7, I can just do xx equals 8 in like the next line, and I'm like updating it, right? On the other hand, if I have final int yy equals 7, if I want to do yy equals 8, this is illegal. This will not work. This yy equals 8 will not work because I declared this integer to be final. Final means it's like in its final form. It's not going to be, it cannot be updated, basically. However, it only means you cannot reassign. So it's like funny thing happens where if I have like final h4, final human h4 equals new human, John again, because I'm uncreative. John's 14 years old. So if I want to do h4 equals new human, Jesse 15, this does not work, all right? Does not work. Yep. However, just because h4 as a variable is final, it doesn't mean like this object can't change. So let's just say like John grew up. I can do like h4.age ++. This is totally legal. Oh, by the way, ++ is Java way of writing +1, plus equals 1, if you guys know what that is. I believe this is a thing in like every language. This is like equivalent to h4.age equals h4.age +1, basically, that thing. So that's plus equals 1, and if it's like you're only adding one thing, then in Java you can do ++. You can do -. It's very convenient. All right. So yeah, so this is allowed even though h4 is final, because it only means that h4 cannot point to any other human, but it doesn't mean that the specific human cannot change. Does using final save space? Using final does not save space. You would want to use final if final helps make your code more bug-free, because if you declare something as final, it cannot be reassigned, so you can always be assuming that it's still going to be the same object. And you don't want your code to like accidentally, like if you forgot or something, accidentally like messed up and reassign it, then it might be like harder to track down a bug. It's like one of those better coding practice, but it's not super important for Battlecode specifically, unless you have a very beautifully written, like code is perfect, ready for production bot, which some teams do, but my code is spaghetti. Other than when I need to publish it, which includes Battlecode. Yeah, our Battlecode, like engine code, is like decently pretty. I have to resist the urge to spaghetti. All right. Yeah. Okay. And then next part, local variables. Nathan, do you want to talk about this? I just cut in.
No, it is fine. Yeah.
Go for it.
Also tell me if this is wrong, because after using different languages, having not touched Java itself in too long. Okay, here's an example. So remember this for loop. I'm going to use completely different names because I want to avoid name collisions. For loop iterator var. Actually, I would run this code snippet, but I think so many of the things up here are broken that this wouldn't work. But basically, if you do this, for, like, as we kind of talked about before, you start up a new variable called for loop iterator var. You use it in here. This variable, for loop iterator var, only exists within the for loop. And so in particular, like, if you were to try to, I don't know, if you're trying to print it out here, this will not work because, yeah, the way that, just basically the way that loops work is that if you declare a variable up here for the loop to use, it'll only exist within the loop. And once the loop is done, it like basically ceases to exist. And so this means that also you could have just kept reusing I when we had, when we had two for loops here. When we had two, we didn't. But if I could also now just write this all over again, fix the indents, and this would run fine too, because again, for loop iterator var is different here than up here.
Oh yeah, I'll ask something.
Yeah, go ahead.
So on the other hand, like let's say we did this, I took this out, I initialized it 0, and then down here I'm like, I don't need to do anything. So then I'm going to leave the first condition blank. This is legal. This is not legal because every like sub, I don't know, chunk of the code. So like this, everything in this for loop can access everything like up here basically because it's like, I don't know how to nest it within this overall like chunk of code basically. So this would not be allowed, but but I can however can do this. I'm gonna reset this, so I'm not redeclaring. You cannot declare the same variable name twice, but I can like reinitialize because it's not final. So I can like reinitialize it to 0 and then like make it go up to 20. And then now if I wanted to like print out this for loop iterator val, that would be totally legal, and I cannot type. Okay, yeah, all right, so that works. That's basically what I wanted to add about local variables. So it's like the same as like calling methods and stuff, where if you, I don't know, where do I put this? I feel like this method should not be sitting in the main method anymore, but I guess, yeah, you can, yeah, okay, so like for example, when we call the human, can you scroll back up to the human method with the profit?
Yeah.
So if I'm like profit plus minus equals 10, like let's say I did this, right? Let's say our profit got taxed, so we're not actually making the full profit, we only make less than 10. And then down here, if I create a human, maybe scroll down a little bit to show that. Yeah, so let's say human h equals new human. And now I'm gonna do h.solve cancer profit, let me just int profit equals 100. So I do that. In here, so what will happen is it will print out, I don't know, I'm going to get rid of this part in the profit. It will print out I make 90 solving cancer. But if I do system.out.println profit out here, it will still print out 100 because we're passing in a primitive, and in here, even though so when you're passing the primitive, basically like it exists separately outside and within the method. So as far as like a little bit confusing actually, because unlike primitives, if you passed in an object, like let's say, let's do another thing. add another method where you pass in another human. Human friend. In here, let's say I did friend.age ++ because friend's age changed because they got older while they're solving cancer. So if I have human friend equals new human, oh, this is wrong syntax, by the way. I'm trolling. New human friend, I'm 70 years old. Yeah, so if you call like h.solve cancer with your friend, then inside here, friend's age changed from 70 to 71. And if you were to print out your friend's age outside, this would give you 71 as well out here, because you are mutating the object, and when you pass in the friend, you're passing in the reference. So this is kind of like our h2 assign h3, and then like h3's like Anna changed her name, and then h2's human object changed her name as well. So when you pass objects into a method, it basically passes the object reference. So when you mutate the object there, it will be mutated outside of the method as well. Whilst if you pass in a primitive, then it will not affect what's outside of the method. So this is something that could be the source of like a lot of your bugs if you have a lot of methods and stuff. So just make sure you are taking note of that. There was something about this I wanted to say. Oh geez, train of thought.
I don't know. There might be something more to talk about, but
I want to talk about, okay, because I realized when I was talking about int, so let's say instead of int, we had like string to print. I don't know. I want to print something. If in here, yeah, never mind. Okay, so strings are objects, but they are not. They're immutable objects. So Java has this like special type of objects cut. Like if you make something like immutable, it basically means it cannot change, and that can be handy dandy because you can ensure that it never changes. So let's say we have a string s equals hi. Okay, and then if I want to do like, if I do s plus equals, hello.
Wait, I disconnected a bit.
Oh geez.
Hello. Where are you right now? Which line?
I am on
okay.
115.
You're good.
All right. So yeah. So let's say I have a string, and then I want to add hello to it. What happens under the hood is s got reassigned to hi plus hello, so it will have the value like. I have too many eyes. This is a bad idea. Okay. Yeah, so it will be reassigned to this thing. So s will now be equal to this. Yeah, so. But however, this string never changed. Okay, this string never changed. So if I have like string s2 equals s, if I print s right now, s will be hi, hello, but s2 will still be hi. So this is like because when you do addition on strings, instead of like mutating the string, it just basically adds them together and gives you a new string back. So it's immutability, and strings are weird. So even though strings are like objects with this like capital letter variable type, just make note that when you like change a string, you're not changing the string. You're just making a new string. Yeah. So that's a side note I wanted to add. All right, now we can go back. Code structures. Okay. Yeah, so generally, all your statements will be inside methods. So everything we wrote right here, everything has been sitting in this method called the main method. You can scroll up and show them. The main method is always going to be public static void main string args. You can name args something else if you want, but don't worry about it. Main method is like the entry point of like every Java program, and yeah, that's public static void main string args. You just memorize that. It is what it is. You'll understand it in the future probably. So yeah, everything, all your codes and statements have to be code that you want to be ran. All your statements have to be inside methods, and in general, all your methods are within classes. Which, as you can see, we have a class main. That class can be called literally anything else. It doesn't matter. Which obviously, like, we can have like class human and whatever. You can have like classes within classes, which is why we can have like I don't think our class human can be within the main method, but it can be within the main class. So if we like copied it outside, then everything would like actually compile and run. Which is why we're saying that this code is broken, because I just put the class human inside the main method. On similar note, yeah. So now I want to talk about this. All right. So as you probably saw, a lot of places we've been using this word public. Public means anything can access. So you can, and what anything means is I'm saying code from other files can also access. So like, for example, because like if I had like my solve cancer method was public, right? So if I have like another file, like let's say in robotplayer.java, I made a human and I wanted to solve cancer, I can do that because solve cancer is a public method. So even though my code is in robotplayer.java, it can solve cancer. On the other hand, if I label something as private, then only code within the same class can access that. So stream quality. Good, pretty good. Stream seems fine. JK. All right. Private means only code within the same class can access it. So if my solve cancer method was private instead, then if I, where's my solve cancer? Yeah, solve cancer is here. This is a terrible idea because we have 3 solve cancers. Let me make a new method. Private void sing. All right, let's say my sing function is private. Then any code outside of the human class, which is actually a lot of code, like most of the code we've written is not within public class human. Any code outside of this class cannot call sing. So like right here, after I made h, if I want to do h.sing, this would not be allowed. Like this is illegal. Cannot do that. However, if I'm solving cancer and after I solve it I'm happy, I can do this.sing, and that works because this code is within the human class, so it can call anything that's like private in the human class. Yeah, so this is also a way that we like limit a lot of the code within our engine so that you guys won't be able to access it because it's illegal for you to access it. We make things private so then you can't actually use the code. And then another thing that you probably won't use in Battlecode, but I'm just going to briefly mention is you can have...
Elizabeth, if you've been typing, you've been like you've been frozen. If you've been typing.
Oh, you're just not scrolled up.
Where? Oh, that was the other thing I was going to ask. Where have you been typing? Because I scrolled down.
I'm sorry.
Where are we?
I'm so sorry. In the human class.
Yes.
I made a sing function. Okay, yeah, I'm just going to go over this
again.
Quickly. If you scroll down a little bit. So I made like a new new human. H equals new human. Are you frozen? Yeah, that part. Yeah, so this h.sing. So this is illegal. I cannot sing because this h.sing code is outside of the human class. This doesn't work. Within the human class, if I'm like singing after I solve cancer, that is allowed. And yeah, I think we briefly mentioned this, but this is a keyword that basically refers to like the current object, like the object. And this can only be used like in the context of a class where you can create instances. Like it can only be used in like instance methods, because instance methods are like things you do on specific instances of objects, and then this would be referring to that instance. So that is basically, yeah, private methods, you can only access it within the class. There is another thing called protected in Java. I don't really know where to demo this. I don't want to make a whole package.
Yeah,
so briefly explain is only code that lives within the same package can access it. So I don't have to be in a human class, but if I'm in the same package that the human class is sitting in, then I can access it. But if you're in a file that is not part of the package that the human class is in, then you will not be able to access anything that's protected. So yeah, that is basically, you probably won't run into it, but that is the gist of public-private on things. Yeah, so now you can like vaguely, okay, the other thing, did we talk about methods yet? You talked about methods,
vaguely,
right?
Yeah. I don't think we formally defined them, but yes.
All right, can you scroll down? I want to like explain, scroll down.
Yeah, wait, how far? Or which line number are you on?
At the bottom, 254.
The auto thing, this cursor that like tells me where you are also is like not fully functional.
Apologies. All right, so I realized we didn't go over this because I'm not used to lecturing. Okay, so if you want to make a method, actually let's just make it outside of the main method. So it's like an actual freestanding method. So you can do like public, static, let's say void method. My method, it takes in like int number. Actually, a simple way, sum. Let's do this. Int n1, int n2. Yeah. So now, yeah, I'm just gonna write this. Yeah. So this is a very simple method that will sum two numbers after you pass it in. So the basic syntax for methods is you write public, private, protected, whatever in the beginning. So it's like accessibility of the method. You can leave this out, and then it will like default to public, I believe. But just don't leave it out. Static, if it's like you want anyone to be able to call this without an instance of this class. So in this case, because we're in main.java and we're all within the main class, if you don't have a main instance, you can call this method. You don't need a main instance to call this. And then the third thing that comes here is the return type, which in this case, we're returning an integer. And then the name of the method that you can define whatever you want. And then the parameters, which would be type, name, separated by commas. So you can have like an infinite number of these if you want. And then you can do whatever you want within the method, and then you can return it. So if I were to be like system.out.println sum 3, 5, this will print out 8 because that's what happens. However, any code in here, I cannot access the variables in the main method because this method is not like a sub part of the main method. So I cannot access like my age, age2, all those. I cannot use them. If I want to use them, they have to either be like passed in as a parameter, or they have to be like accessible by anything in the main class. So like global variables are a thing, but I don't know. Battlecode specific, we have like a lot of communication restraints and stuff, so you won't get to use many global variables. I guess you can within your like robot player if you want. But yeah, this is the simple example syntax of writing a method right here. So yeah. All right, and now, I guess we just keep going for enums and stuff.
We like talk about static versus instance things.
Yeah, can you go to
direction, I think?
Direction.java.
I'm gonna uncomment, or you can uncomment this for readability. Don't run it. Here we go.
Yeah. All right, so this is direction.java, directly copied from the engine. It is an example of this thing called an enum, also known as enumeration. So Java enums are used if you have like a fixed list of things that are of the same type, and there is never like more than that list of things of that type. So simple examples include if you have like days of week, and then you have like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or you have like, what else is a good example of enum? Months of year, then it's like January through December, but there will never be anything that is not January through December. So as you can see in this direction, just ignore all the comments because I directly copied it from the engine. We have 9 directions defined, and there can never be more than these 9 directions. Yeah, one of them is center. It's not a real direction. We just have it. And then like within this enum, it like functions similar to a class where you have instance variables. In here, public final int, dx, dy are our instance variables. Yeah, you can declare multiple variables of the same type on the same line. And when the direction is created, we assign like x, y to like the numbers that we passed in, which you can see like north is 0, 1, southwest is -1, -1. So this is like basic example of like using an enum. You can have methods within your enum. These are all instance methods because they don't have the static label. So as you can see, a lot of them use like this in it, and some of them have parameters, some of them don't. And then I guess the thing to know with enums is you can use ordinal to give you the index of the specific enum instance you have. So in this case, north would be 0, northeast would be 1, east will be 2, southeast will be 3, etc. So it's basically like ordered in the list that you listed them in the enum. Like ordinal is a function that will give you, so you can do like, you have like a direction D, you can do d.ordinal to give you the index of D. And then direction.values with like direction, the name of the class, will give you like an array of all the values. So that is how you would do it. And can you go back to main real quick?
Yeah.
All right, so enum values are treated as ints. So if I were to use the direction, I'll be like direction. I can do int dir equals like direction dot north. This is allowed because north is basically a number. It's 0. We're just defining like if you're of type direction, you will only be between 0 and 8. I can also do direction dir 2 equals direction dot south. So this is like all okay. It's treated as integers. Yeah, actually no, might have been this. Yeah, something like that. You can treat them as integers, and then, but yeah, you can use the names. The use of like enums is mostly for like your code clarity and to make things like more obvious, more readable. Because now you immediately know you're using north and you're representing north as like 0 whatever. If I always just use like 0 1 2 3 4 for my directions, then it's like really confusing if you forgot. So enums are used like quite a bit throughout the engine. So feel free to explore. Robot types are an enum too because there's only a fixed number of types. So yeah, they're convenient. Interfaces are the other thing that we used a lot in the engine. An example is bodyinfo.java. Will you be able to go to that, Nathan? Yeah, so right here in bodyinfo, as you can see, instead of public class bodyinfo, we say public interface bodyinfo. And I guess in general, an interface is like, I'm going to list some things that I would like to have for anything that's a body info, but I'm not going to implement them. So now, as you can see, we have some methods that are defined here that we're like, okay, we want this anything that is a body info, it should have these methods, right? But we're not going to implement how specifically it will go. So I guess go back to main. I'll give like a nice quick example. Yeah, so once again, this code is not going to compile because it is sitting inside a main method. But I can, like, for example, if I made an interface called like vehicle, right? Did I spell that right? I can be like, every vehicle should be able to be driven. So I can do like public void drive, right? So this is something that I want everything that's in vehicle to be able to do. And now I can do public class car implements vehicle. So now I'm defining a class that implements this specific interface. And if I want to make this car class work / be legal / be able to be compiled, then I have to define in here drive, and in here like the code that makes the car drive. And then this is convenient because I can also have public class truck implements vehicle, and then it must also have the method drive. So this is like convenient because this drive might be implemented differently based on whether it's a car or a truck, but as long as I have a vehicle, I am guaranteed that it will be able to be driven, which is like really nice. So if you scroll up a little bit back to the sets, maps, lists part, basically list is an interface, and you can implement it. It's implemented in Arraylist and linked list and etc. Set is an interface, hash set and tree set implement the set. So like all these methods that I'm calling, they are set methods. So any implementation of the set is guaranteed to have like the add method, guaranteed to have the size method, which is really convenient because then you don't really care about how they specifically implement it as long as they implemented it. Map is the interface, and then hash map and tree map are the specific implementations. So you could totally just be like tree map. Oh, you can't see it on the screen. Are you scrolling,
No,
Nathan?
sorry, I was chatting too. Wait,
where are you? That's fine. Just down a little bit. So down here, like map is the interface. You could totally just declare hash map, this new hash map. But I think the general convention is you just want to declare map because you don't care about the specific implementation of the hash map, and this makes your code like more reusable. I guess you can just swap this out to a different implementation of map like really easily, and everything's still guaranteed. Yep. Yeah, so I guess like on that note, Java also has like abstract classes, which are like similar to interfaces, except scroll back down to the interface part.
Yeah. there.
So if I can make another interface called like public interface cool stuff. All right, and it's currently empty. So I can do car implements vehicle cool stuff. Yeah, so this is cool because a single class can implement multiple interfaces. However, if I do public abstract class, that is not the way. Public abstract class. I don't remember if you have this. I think you do. I don't know. Four-wheel vehicle. Yeah, so if I do this, I can only, instead of implements, it will be extends four-wheel vehicle. And then, yeah, so I guess like a example of this being used is this abstract class can implement vehicle. I have so many typos. Yeah, so the abstract class can implement the interface, and then your class can extend four-wheel vehicle, but this, you cannot extend more than one abstract class. And I guess like also another big difference between abstract class and interface is in here, you can actually have like instance variables, whatever, and you can have like implemented methods. So you can like public void, dude, donut, I don't know. And then you like actually type it out, and it actually does things. So you have like, this is called concrete method, and abstract, you can also have abstract methods, which you don't like define. Some abstract method. So you do that. Yeah, you just put like a semicolon behind it. This might not be like 100% syntactically correct, but this is like the main idea is your abstract classes, it can have like abstract stuff that doesn't need to be implemented. It can also have concrete stuff that is implemented. And if you have like a concrete class, which is like a class that doesn't have like abstract in front of it, it can only extend one abstract class, but it can implement multiple interfaces, and interfaces cannot have concrete methods. So the biggest example of this within our code is robot controller is an interface. That's the API that you guys will be interacting with. And then robot controller implementation is the implementation of that interface, and that's like the code that we wrote that actually implements all the functions that you guys will be calling. So you guys can call anything in robot controller without like even knowing how it's specifically implemented, but like if our code is not buggy, then it's like guaranteed that it will follow the spec and do what you want it to do. All right, so that is our how to Java. No, wait, there's another last section. Yeah. Go for it.
Also, can you like pull up the Java docs? Can you find a link to some nice Java API? Because I forgot to do that.
All right.
But that is coming later. Double equals and dot equals. I'm going to call this dot. Well, it doesn't matter. So for primitives, the way that you check if two things are equal is just like the normal process. I don't know. True. I think this is well, okay, that was actually, that was meaningless. Okay, yeah, check if things are equals, true. It gives you stuff. This works for primitives. For objects, it's a little bit more complex. And so, what are some objects we have?
Human.
Let's do human. And let's say you have two humans, right? Equals equals the the symbol checks if, what is it? I should have used some better.
Memory.
Yeah, I should have used
memory location.
I should have used some better things. H5 and H6. H5 points to a human. H6, as we've kind of talked about before, this creates a new human object. A different human object. And so the equals checks if H5 and H6 literally point to the same things in memory. And in this case, they don't, because H5 and H6 don't actually point to the same thing. On the other hand, and we didn't actually define this properly, we should define an equals method.
Yeah, just scroll up and make it real
quick.
So
on the other hand, equals is a method that most of the built-in Java classes have to do more nuanced equality checking. It doesn't exist for human, but if I was to write one,
I'm gonna make it right now.
You can make one, yeah.
Oh, I forgot to say this, but if you're like implementing something that like an abstract class or an interface told you to have, then you should have it would be good to have the override tag.
Yeah.
I believe you scroll down a little bit. I'm at the bottom of the.
Oh, you're putting it up. You're putting it up down there. Yeah.
Okay, your override stuff usually all goes at the bottom. So, what this is overriding? It's overriding. Let me just do this first. Public boolean equals human other human. So this is you're overriding some equals method that already exists, and it exists.
Oh.
Whoops.
You go ahead.
Whoops. So it's overriding the equal that exists in object, which is the class that like every object you ever create in Java is going to be like something that extends / implements object. It's, yeah, as you can see here, it's like capital O. This is a thing in Java. So this object, every object in Java has equals, it has toString, it has like hash code, like some of these properties that are like commonly used. And a lot of these are like the default equals of your object, if you didn't like properly define it, I believe might just be like memory location. So it's like the same as the equals sign. But if you actually define this equals object, you like check, oh, if the name is the same and if the age is the same, okay, you need to put spaces here. Come on. Then your equals will actually check equality the way that you actually intended to do. You know, so that's like very helpful in like having this stuff. And yeah, just make sure when you're checking equality of objects, you're actually checking equality and not just checking memory location equality, unless that's what you actually intended to use. Yep.
Yeah. And so all this means that if you were to, now that we've actually defined like more meaningful or more useful equality methods, true, because they match the same as they have same name and age. Java API, yeah, that's basically the gotcha for equality. And I guess if you're writing your own classes and if you want to write your own equality method, you should probably just make sure that like it's because you're custom defining things, it should make sure it's what you want. As in like, you know, you should be checking that fields are equal. You should make sure that plenty of other things, but just make sure that like your method does what abstractly you want your equality method to do from like a design standpoint. That's more or less enough about that. Java API documentation. Java has like generally really nice documentation out here online. You can like, if you were to look up like, what is a set, it gives you, pretty sure you should have gotten Java 8, but whatever. Let's do this should work, right?
It's mostly the same.
Yeah, I was gonna say it's mostly the same, but like, here's Java 8. Java tells you like, this is what a set is. Here's a lot of information about the set. Here's some related things that you might be interested in. Here are all the methods you can use for a set. Like, how do I add to a method? Oh, how do I add?
Scroll down. That's the methods.
Wait, these are methods. Are you lagging?
Oh. Wait, you're not sharing your screen with me. I'm watching the Twitch on like 6-second lag.
I'm looking on my own laptop, or my other laptop. The stream seems fine.
Oh, you know what? Just keep going. Just keep going.
Are you watching? Did you tune off? Feels bad.
Wait, what?
I'm trolling.
Okay.
An add method. If you forget, like, oh, how do I remove something? I think, oh well, not what I was looking. Like, oh, if you look through this, how do I find it? How do I get the size array? Oh, look, this exists. Blah blah. Gives you info. This is especially, well, I guess this is, the idea I had was more applicable to Python. But it's good to, like, Java just generally does have really good documentation out there. And if you ever need to look something up, it's out there. Yeah, there's probably stream delay. Elizabeth is in a funny place because our call is live, but she only sees my screen 6 seconds later, give or take.
Yeah.
Yes, lots of info. you can, what's a null pointer exception? I don't want to go there, but Java will tell you. Less time spent on that, the better.
Okay.
And furthermore, not only do these, so that tells you a lot about Java, and also if you want to look up, other, like there are plenty of other good tutorials, good sources about Java too. Hopefully this works right now. We should really change, okay, I should work on changing that to say Battlecode 2021. But we have also published generated Java docs too for our classes about the game. And Elizabeth, are you going to go over the robot code still?
Yes, sorry. I'm like terrible at estimating how long a lecture is going to take. I know, I'm terrible.
Hour and a half, whoops, sorry. Okay, I'll keep this quick. So we provided you guys a bunch of classes. We also generated our own documentations. Kind of like this, well, like roughly with the same format and stuff. We game constants as a class, and we give you like all their fields. We give you, well, not that they're methods, but we give you what the methods would be. That sort of thing. Battlecode 2021, right, we link it on the site. I don't know, go find it. Yeah.
All right. I want to answer this person's question. All right. So assigning null pointer exceptions will happen. So if, for example, if I made like a human array, my array 2,
Wait,
3.
Where are you right now? Which line?
Near like.
Wait, do you not have line numbers? 283. You do, right?
283.
Oh, you're lagging. I can't see it.
I'm lagging.
Yeah.
Never mind. All right. Null pointer exceptions. So if you make like an array of objects, all of them, the default value for objects is always null, because they're not going to just go in and fill in every field, every like instance variable with like the default instance variable value and like keep recursively doing that. So the object arrays you create and stuff like that, the default value is going to be like null throughout the array. And yeah, after you like populate it, it won't be null anymore. But you do want to check for something to be null. Like if your code doesn't guarantee for something to not be null, you should check that it's not null before calling a method on it or something, or else you're going to get a null pointer exception. So this shouldn't be too big of an issue, question mark, maybe. And yeah, so that's why null pointer exceptions exist.
Go ahead. Or if you're done, you want to talk about importing too?
Just very quickly. All right, importing. Things you might find helpful to import java.util. So I guess like I don't even know if you will need this for Battlecode that much. So you can import things in the java.util class by doing like java.util. The thing you want to import. So examples would be like collections, java.util.arrays to use like arrays.sort. Like arrays.sort, you would need to have like this class. If you want to import everything in util, you just put a star, and then that's like everything under the util package. Similar stuff is like java.math, except like by default, you can access java.math in like all of your Java code. There's a lot more like Java packages like out there that would be useful when you program in Java, but for Battlecode specifically, we restrict your imports because, some things are not allowed. So you gotta check I believe at the bottom of the spec, there are like restrictions on imports that we disallow.
There's like a whole page of, there are also tables of like what is allowed and what's not.
Yep, so your code will not run if it does illegal things. All right, now we can go over robot player.
Please, let's just, yeah, you got it.
So this is the copy-pasted code of the robot player that we provided you. It's very simple. It doesn't have any like strategies involved, but this is like your basic robot code, I guess. So up here, as you can see, we made some static final variables that basically store like things that we would want to use. So instead of like listing this out, we could just do direction. Like we could do direction.values, except this will also include this central value that we might not want to use, which is why we like define like all the directions we want to use and all the robots we want to spawn. So that is there. Static and turn count. This is also just here. You don't actually need this, but this is like very helpful in if you want to like debug things and figure out like which turn you're on. So the base bone of how your code is going to work is you have a run function. that you have to define in your robot player, because we will call this run function. The run function has to take in a robot controller, which is basically 69 people watching 420. All right, okay, I'll stop getting distracted. So it takes in a robot controller, which is, if you saw our large Java doc, that is a robot controller, and you can like call anything that like the RC API exposes. This has to throw game action exception, because you can have game action exceptions when you use the controller. In here, you have a while true loop. So this is like kind of how our engine is structured, which is like maybe not the most intuitive, but basically you have like your robot player is going to be running on every single copy of your robot. And between your robot taking turns, we basically like pause your thread, and then we just resume running right after. So that happens at like clock.yield. Like it basically means that like you're waiting until your next turn. And like if you run out of bytecode, we will like stop your robot. But here you can like stop it by yourself. Like you can stop it yourself, be like, I'm done with my turn. So that's why everything is in a while true, because we're not going to recall. We do not call run multiple times. We kind of like call once, and then you're just like in here, and then you can like pause, wait for your next turn, and then it will like keep running. So that is why everything's in a while true. And here, as you can see, we like increment the turn count in here, because like every time like after clock.yield, you just like run the loop again. So each iteration of the loop is like one of your turns. We put like the main code inside a try catch. You don't have to do this, but it's like highly recommended, because if your bot throws an exception and you don't catch it, your bot just like will no longer be functional. Basically, we will like freeze it, and then it will no longer function. So we put everything in the try catch, which I guess we didn't really go over in our Java lecture, but basically it's like everything inside the try block is code that you want to run, and catch takes in the parameter of like what kind of exception you want to like catch. It's like kind of like a net to make sure your code doesn't explode. You like catch it before like all falls into oblivion. So you like here it says like I'm catch like any type of exception, I will catch it, and then I will like do things based on it, and then my code is like fine. If you don't catch, your code explodes basically. If you have an exception and you don't catch it, it explodes. Terrible analogy, but so basically this is the code that you actually worry about from line 46 to line 52. This is the code that your robot does every turn. Yeah, so that's like how this code is structured. And in here we use a switch statement. More Java things. Switch, basically you give it a parameter, a thing. This is usually, you can only do like ints or strings or something like that. And then it will check the thing you passed in against like a bunch of different cases you listed. And then if it matches a case, it will run everything starting from that point in the code, and it will stop until it reaches a break statement. Yeah, so other useful Java things are break and continue that do like, I don't know, I want to go over this. Okay, so break, like if I have like while x, while true, and then if I break, actually this is a terrible idea. While x is less than 100, let's say I have an x, I'll do like if x equals 50, break. Yeah, so this is basically like if x reaches 50, I will break. But if I do like x plus equals 3, and then I started with like equals 0, then it will never reach this x equals 50. So it will never break. Break means it's just like it cuts the loop short. And then another thing is I can do continue. So how does this? Oh yeah. So I can do if x equals 50, continue. So basically if this condition is true, I will like no longer execute whatever code is behind it, and I will like proceed with the loop, like the rest of the stuff in the while loop. Yeah, so these are like useful things you might want to use. So it's basically like continue the loop on the next iteration and like skip everything that's like the rest of this specific iteration of the loop. Yeah, so in the case of our switch statement, if rc.getType is equal to enlightenment center, we will run enlightenment center, which is a method that we define, and then done, we're done. And then on the other hand, like if we didn't have this break statement here, what's going to end up happening is if it's an enlightenment center, it will run this, and then we'll keep going. It will run politician, and then it will be done. So that's why the break exists, and then it will like basically check against these 4 types. And if you want, you don't really need to like like a basic bot, you don't really need to change anything in here in the run function. You can just go down here and modify the rest of our functions. Nathan, do you want to scroll?
Yeah.
So we have like some example functions on like what the different type of bots would do, and they're called based on like what bot it is. If you scroll down a little more, we have other functions that we define that are like helpful. So direction, random direction, it basically uses math.random to sample like a random direction from the list we define at the top of the file. Random spawnable robot type is also like, it just picks one of the 3 types that you can spawn. And then we also have like a try move that's like, it basically like tries to move in a direction, and what it does is it calls our like can move, and then it like actually moves if it is able to move. Because if you call rc.move without checking that your robot is able to move, which is like conditions like, oh, you're moving to an adjacent tile, or you're like, well, if you give it a direction, then it's guaranteed to be adjacent. But if you don't have cooldowns, for example, then you cannot actually move, and the move will throw a game action exception, and throwing exceptions is expensive, so you do not want that. So you can like always like do can move and then actually move after. And then, yeah, this function like returns like true or false based on whether or not the robot was able to successfully move. You don't need to keep any of these functions we wrote. You can change it up however you want. This is just kind of like a bare bone example. So if you scroll back up and look at like run enlightenment center, our bare bone enlightenment center basically tries to build a robot in a random direction. And that's it. That's all it does. And then it bids at the end of its turn. You can bid an infinite number of times if you want, but like only your last bid is saved. Everything else is erased. What happens if 2 robots try to move in the same tile? So that can never happen because robots take turns. So how internally our engine works is we have a list of robots. They are in some certain order. When you spawn a robot, that robot gets added to the end of that list. And then on every round, like every robot gets a turn, like 1 by 1, based on the list in the order in that list that we have. And a robot can go only after like the robot before it is finished its turn. So yeah, like if 2 robots try to move to the same tile, the one that goes first will get there first, and then the one that goes after will not be able to go there. Or their like can move will not return true because it's occupied. So, and then like run politician, like very basic things. I guess it's not too basic, but what we did here is like, all right, I'm gonna try to see if there's anything near me that I can attack, and if I can, then I'm gonna attack, and that's it. And then otherwise, I'm gonna try moving. And then slander just moves in some random direction. Muckraker, it also like if there's anything within its like sensing radius that can be exposed, then it does that. And otherwise, you just like try moving in a random direction. So this is like pretty simple bot. Don't be scared by the number of lines in the code. And yeah, that's basically it. You can get really creative with all these functions and methods and write your own and everything. So as you notice, everything here is static because you don't need an instance of robot player, which is the name of the class, to do any of these things. And also, oh yeah, there is a static variable called robot controller RC, and on line 35 we assign that to the robot controller from the run function. And the reason we do this is so that all our other methods later on can use this robot controller, even though the robot controller is not a parameter in their functions. So this is kind of like a global variable. Global variables are basically like static things that are at like the top of the class, and like everything in the class can access it, yay. But yeah, that is basically it. If you have any questions, I think we'll look at the Twitch chat. But otherwise, we're done. Now you know Java, question mark. And have fun with your bots. I'll tell the lecturer tomorrow and see if they can do a getting set up demo and stuff. With the Gradle build given, yes, the build given is you're running the teams with the same code. And they will not have the exact same behavior because of the math.random, but like every time you run the match, the same thing should happen because we have a deterministic engine. example of spawning bots after a certain type of influence. Yeah, so you can put that in the run enlightenment center and be like, if rc.getInfluence is less than some amount, then you just like don't do anything. Exposed, yeah. Where does this check cooldown? Yeah, so whenever you try to do something, if that action is an active ability, which is building, moving, empowering, and exposing, it will check for you that you have like the valid cooldowns. Why did blue seem more dominant? Yeah, I think it's just they got like the edge on their math.randoms. If there's a setup tutorial, could it be on VS Code, please? I will ask. I cannot guarantee that Quinn uses VS Code. But yeah, tomorrow it will not be me lecturing. It will be another person. Our infra guy, I believe. Unless we had a change of plans that I'm not aware of. Can we schedule which bots take turn first? You can schedule that by spawning them in that order. They are added to the queue in the order of spawning. But that's it. You cannot otherwise like switch the order if your bot's taking turn. But like, if you think about it, like if you wanted your like later bot to move first, you can just make your like earlier bot like not do anything for a turn, and then on the next round they take their turn, which is like effectively after your bot that's later in the queue. How do you get influence? You can call rc.getInfluence and it returns the influence of that specific robot. If you want to know the influence of like other robots, you like sense them and then it's in the robot info, which is stuff on our API. Yeah, our robot controller has like a large number of methods. You might want to like skim through all of them so you get an idea on what you have. My head just spiraled. Sorry. Yeah, I know. It's like, I know the JDK8 is like really terrible legacy feature of the engine. Yeah, deepest apologies. We one of the things that we're thinking of is just like kind of like refactoring the entire engine before 2022, along with like a lot of other things that we're like, oh, it'd be cool if Battlecode had this, it'd be cool if Battlecode had that, but then we procrastinate and get busy because we're all students too, so a lot of things don't end up happening. But refactoring the engine is something that we actually would like be willing to invest effort in, so we'll see if that happens for next year. And then there won't be like annoying things like Java 8 or flat buffers, which are like how we do the replay files right now. They're kind of terrible. They're like very efficient, but they're kind of annoying to use. Hey, for funky Java setups. Has link for the game download. Nathan, can you send the link for the game download?
Yeah. Wait, it's all in like getting started isn't quite the link itself, but it tells you where to find.
All right. So like most of like the code that you care about is going to be in robot controller implementation, which is like free for all to see on our repo, and that's in like, so like all the things you have access to is in the common folder. All the things that we wrote that might be relevant to that you would like possibly want to read, but you can't directly access, is in the world folder, and robot controller implementation is in there. We do check for the cooldowns in like all the active methods that you call, active ability methods. Yeah, something like that, except you're, so I'm looking at so something like if rc.getInfluence less than 50, yes, but parentheses, because it's a method. Ooh, we'd be happy to help after a season. Damn, that would be nice. Yo, join the dev team. Actually, are you allowed to join the dev team if you're not at MIT? Well, I'll ask Jerry. I think our president just like decides how everything works. Or like we all discuss, but you know, when I don't want to make a decision, I ask him. Jerry is cool. Jerry competed in Battlecode for like many years, and then he's like a really good competitor. Like comes to MIT for final tournament, and then he came to MIT, and now he joined the dev team, and now after a year he's like our president because he's very cool. I think like a lot of the older competitors in the Discord actually like know him, and so yeah, when Jerry says something on Discord, people are like, oh, it's Jerry. what is the lecture tomorrow going to be on? So tomorrow we are going to be like how to Git, like an introduction to Git, which if you're like a person working by yourself, it's not like completely necessary, although it's still good. And Git and GitHub is basically a set of like version control techniques. So think about like Google Docs, and you can go back in the history. So it's like that, but it's for code, and it's like super, super nice. Yeah, and then also like setup if I get Quinn to do that. Only found out about Battlecode Senior Field Batman. Yeah, it's unfortunate. Hey, you can always participate in Battlecode even if you can't get prizes. We have like one like competitor that's like always here. He's like here for like many years, but he's not eligible for prizes, so he only like does the sprint tournament. Yeah, so this hasn't been like released yet, but we are considering like not having seeding tournament and just have a second sprint, because we've like received lots of complaints from competitors about the seeding tournament, because I guess like it's difficult to like tiebreak between like number 65 and 128 or whatever, and yeah, and also it's just like your code will change a lot between week 2 and week 3. So like the results from the seeding tournament is not even like that descriptive for who should get the better seeds in the quals tournament. Someone donated 1,000. Huh? What are we talking about?
No,
I'm confused now.
Just try.
I'm so confused. More directly, all your codes in Google Docs. That's beautiful. People have done that. I believe I've done that at some point too.
Nate said his team did that for Battlecode itself, and he does not recommend it
yeah,
anymore.
so Nate is the. I almost said Jerry did that, but I'm like, it doesn't make sense for Jerry to do that. He is a coding god. Professor Foss, dude. Professor Foss is the GOAT. He's like professional and concise. And I'm like the exact opposite, but I'm just here to have fun, so whatever. The Git lecture tomorrow. Yes, the Git lecture will be tomorrow. Where's Prosper? Prosper is downstairs. Prosper is my cat. I think we're done here. If you guys have any more questions, feel free to ask us on Discord or send us an email. Discord is kind of scary sometimes, but I'll open it every day. Yep. Google Docs is Turing complete. Wow, I didn't even know that. That is cool. Recommended date to start programming. You can start today. Yeah. Although if you would like to use GitHub with your team, then maybe you need to like sort of figure out how it works tomorrow, but you can certainly start like strategizing and thinking of how you want things to work. We do recommend like starting programming like today or tomorrow, because our sprint tournament is like a week from like yesterday, or a week from today. It's January 12th, I believe. So yeah. Alright.
What? Why are you texting me now?
Yeah, I'm telling you we can stop streaming now, because I think we're done.
We can streaming now, behind the scenes. We can streaming now. Well, I don't get it. We're already streaming, so okay. Hello.
Alright.
I kid.
Yeah, but I've run out of things to say. I can keep sitting here and answering questions, or I can go eat dinner.
Ask us things. It's 8 p.m. for you, isn't it?
Yeah.
Yeehaw, Texas, something.
Battlecode
client has a sleep icon. Yeah. So a lot of our
legacy.
A lot of our README until last week read Battlecode 2020, or like BattleHack 2020, and yeah, a lot of like the graphic things, a lot of like the text we display is out of date, and we should do that soon. Eat questions and answer dinner. Eat dinner. How about you? How about you eat dinner? Yeah. Eat dinner. Central Gang, who are you guys?
They are the supreme race of human beings. That's what.
One beach. Gulf of Mexico beaches are some garbage. Can't compare.
Yeah, Nathan is in Pacific time, sitting in California.
The part of California where the beaches are, actually warm. It is. Yeah. I was actually curious. Is anyone here from Mountain Time? I don't know if any Battlecode devs are in Mountain. I don't think they are.
I think most people.
Most people aren't Mountain. Oh, Teresa's. Thank you. Yes.
Completely random information you didn't ask about. But Battlecode, we have a lot of people international. Like Jerry is in Australia. Hoon, our client lead, is in Korea. Gav, who lectured with me yesterday and is also on the client team, is in Hong Kong. Arvid's in Sweden. Arvid the goat. Oh, yeah. Arvid did a lot of the stuff last year, and this year he's like kind of sitting back a little bit more because he wants to retire so he can compete next year and destroy everyone. And we're just like, Arvid, you should say, but yeah.
He's been angling to try to make a team of former devs too. Unsure how many.
Oh my goodness! Is he gonna like try to make all of us retire too?
Well, yeah, he started the machinations last year. I think there are people certainly interested in joining them, and this is going to be just some like. I am intensely worried because they know their code. They know the dev code base more than anyone. And, security flaws.
Imagine being like familiar.
Yeah, so
with
at staff, this has been something that I've been thinking about for like since last year. That people are that like we have plenty of former devs on stuff, which seems a little weird. Yes, feel free to leave unless you want to just miss out on us chatting and like reading Twitch chat.
Yeah, you can. Yep. I want to eat dinner. I'm hungry. Okay, I'm gonna leave now. Goodbye, guys. It was nice chatting. You guys are fun.
I should go get some food too. I'm gonna hop off. If you have any outstanding questions, Discord exists. Pew pew.
Yeah. If I hope you liked the lecture. If it was terrible, we've never lectured about Java before.
Can I give your Twitch some publicity? Sub there.
What? Oh. Oh my goodness. Wait, I don't even stream, so why would people follow me? Although, this is kind of fun. Maybe I'll launch my streaming career. Alright. I'm gonna go.
Goodbye. Thanks to everyone for sticking around and all the chatting.
Yeah,
it was really fun. Bye, everybody.